Good afternoon, ladies and gentlemen. Welcome to TechGeek webinar series, our endeavor to empower techies. We believe that sharing of knowledge is the key to enhance our skills and grow us as professionals. With this principle in mind, we have initiated a series of webinars conducted by industry experts to give you all a crisp insight of various domains. The topic of today's session is SQL Server 2014 Enhancements for Always-On Availability Groups. Our guest speaker today is Mr. Vijay Rodriguez, Support Escalation Engineer, Microsoft India. Mr. Vijay has worked on the SQL engine, SQL connectivity, SQL replication, clustering, always-on availability groups, in-memory OLTP, and related Windows Azure IaaS issues. These involved deployments from few users to deployments with critically impacted millions of users. He is currently working as Support Escalation Engineer in the SQL Server team, always-on specialty with Microsoft India GTSC. Prior to joining Microsoft in 2005, he worked for approximately 3 years in business development, then around a year in customer service operations. His graduation involved computer applications, then a postgraduate diploma involving information technology. So without further delay, I introduce you all to our guest speaker. Over to you, Mr. Vijay.
Okay, thanks, Shweta. Hi, everyone. I hope you can hear me. My name is Vijay. As Shweta said, I work in the AlwaysOn team. Yeah, and I've been in Microsoft for a few years now. This presentation that we're going to do today is on SQL 2014 enhancements for always-on availability groups. For those who may know about this, always-on was introduced as a high availability offering somewhere in SQL Server 2012. Prior to this, we had other high availability offerings like mirroring, SQL failover clustering, and so on. But always-on sort of combined the best of mirroring, the best of failover clustering, and it had many more advantages. SQL 2014 is enhanced even more, and in this demo I intend to show the enhancements for SQL 2014 for always-on availability groups. So let's start. Okay, I'll just go with in a presentation mode, and then I'm going to show you a few demos. At the end of this session, there will be time for questions, and there should be quite a good amount of time. So in 2012, when always-on was first introduced as always-on availability groups, we had one primary replica which would be in read-write mode, and there were 4 secondary replicas. These secondary replicas could be in read mode. So that means an application could distribute the load by doing read-write on the primary, but then conducting its read activity on the secondary replica. This could be useful for reporting. It could be useful even for the database maintenance, like running consistency checks, check DB, running backups, basically on the secondary replica, so that the primary is dedicated to read-write workload. So considering the secondaries, to be helpful so much for applications and for administrators, SQL 2014 took this a step further. It increased the number of secondaries from 4 to 8. So in SQL 2014, rather than 4, we have 8 secondary replicas. These can be synchronous, or these can be asynchronous. We still have one primary replica for read-write, but other than that, the read activity can be distributed to 8 secondary replicas. In 2012, I mean, if there was any, say, cluster quorum loss, or there was such an issue, or some disconnection from the primary replica, the secondary replicas would go offline, or would not be basically available for application connectivity, application or user connectivity. The feedback, the customer feedback was, the user feedback was, hey, I mean, we want the secondaries to be available even if there is, loss of quorum, or if there is a disconnection from primary replica. So in 2014, this has been enhanced so that even if there's a disconnection, or even if there is a cluster quorum loss, the readable secondaries are still available for read workloads. So it's all in the spirit of high availability. Just because one part of the cluster is down, we don't want the readable secondaries also to be down. Earlier, applications or users, when we had to check where AG was hosted, it's easy, if you use SQL Management Studio. But from a remote server and from an application, we may not be able to use the UI. We had to query DMVs. This was possible, but now it has been made even simpler. There is a function sys fn header is primary replica. Just give the database name and it will tell whether it's the primary or not. There is we will cover some of these in the demo session. One thing that we will not be able to cover in the demo session is the add Azure replica wizard. So always on availability groups can be created on in-premise servers, or they can be created completely on the cloud in Azure. Okay, but they can also, a hybrid of this can also be created. So some servers can be on-premise and some servers can be on the cloud, all part of one cluster. So all doing a failover. This requires a VPN for demo. So that's why this demo, this internet mechanism will not be suitable for such a demo. Because it will all look like anyways a cluster. But this is a feature that's available in terms of, it was available in 2012 also. What's different in 2014 is there is a wizard to automate adding a replica, adding a secondary replica onto the cloud. Database files in Azure, 2014. So so right now, right, we create a database. The files are either on local storage or shared storage or SAN storage, which is almost equal to local storage. Okay, but this was yet another mechanism where the database files could be on Azure. Okay, so which is something only in 2014. 2014 also has managed backups. Okay, and of course, like I would say, this works after failover too. We will not be covering these because these are not straightforward for demo. Okay, but we will try to cover the top two demo. And there are additional supportability enhancements. Supportability enhancements means just for troubleshooting, for getting more information. It's much easier in SQL 2014 rather than 2012. We will be covering this also in this demo. Okay. Going to the next slide, basically, the first point that we talked about was increase in number of secondary replicas in SQL 2014. In 2012, okay, so the screenshots above are of 2 point in time, in 2012, both are in 2012. So the first one, if you take the one on the left, okay, there are 4 nodes. Now, if I click and add replica, I'm able to click simply because it's not grayed out. Okay, but after I click the 5th one, it's grayed out. Okay, simply because like how we discussed earlier in 2012, there was a limit of 1 plus 4 replicas. In 2014, this will not be grayed out simply because the limit has been increased from 1 to 8 replicas. Okay, of course, when we increase the number of replicas, we also have to keep in mind the system resources, will be increased in terms of worker threads within SQL and so on. So, a trade-off has to be made in terms of how many replicas are actually required for business or reporting purpose. In 2012, we used to get that error mentioned in red, which said, hey, number of available replicas and availability group is 5, the maximum number. In 2014, of course, it will be 8, 1 plus 6. Oh, sorry, it will be 9, 1 plus 8. We will be conducting a few demos, and I'll go back to my demo test notes. Okay, there was an issue connecting to servers from this tool in 2012, so I'll just directly go to Windows Windows SE 14. Sorry for not having this video, but this is the last thing that I should have seen. I just try to connect to the info group. So I have a 2012 group for demo, I have a 2014 group for demo. If at all the 2012 group does not work, we'll directly go to the 2014 group for demo. Okay, goodbye. We'll try one last time. Sorry guys, just bear with me a minute. It would be good if this works because we can see a comparison. Otherwise, we'll just proceed. It looks like a direct connection works. So there must be something in this tool, but that's fine as long as it works. Okay, so I have an availability group. This is in 2012. So as you can see, it's 11.0 or something. If I right click the availability group created and click on show dashboard, you can see it's synchronized and it's healthy. If I have a similar thing for 2014, so if I go to 2014, if I go to SQL Management Studio, just to verify, here we can see it's the build is 12.0, so 2014. If I right click the availability group, the first one, and I can see this is also synchronized and this is also healthy. Okay, so let's go back. So we have one primary and one secondary replica for each of these. Yeah. Okay, so now we'll do the first thing in our demo. We'll start SQL on the primary and see if we can see data on the secondary. Okay, so I will go to primary, and so basically this demo is just to show us the differences in 2012 and 2014. So I'll go here, right click, I'll stop SQL service on primary, stop, yes. To save some time, I'll go to the secondary also, and let's stop the SQL service there. In both cases, we are stopping the primary, confirmed. Okay, this is not good. We need to restart. Okay, so we have 14 minutes. So let's take advantage of the 14 minutes. Now if you go to the second node, which was the earlier secondary, and this is in 2012, we can see the availability group in the resolving state. I mean, because it's not able to get information on the primary, and till it's able to connect to the primary in 2012, it will be in resolving state. If we go to databases, we will not be able to even expand or access the databases. So if we cannot expand to SQL Management Studio, definitely application will not be able to use the databases. Okay, let's go to 2014. So we go here. So here we can see the same state as resolving. Okay, but if we expand the database, we can see that we are able to expand the database, unlike 2012, where when we try to expand the database. I'll just refresh this just to reconfirm. You know, we got this error that the database is not accessible. So what that means is, even if the primary is down, okay, even if the primary is down in SQL 2014, we are still able to access the data on the secondaries. So this is an enhancement, right? Because it's higher availability. Just because the primary is down, we are not stopping secondary. Of course, it also means the secondary will not have the latest data, but that's an application decision. If they don't want to access while the primary is down, it's up to the application. Now at least they can make that decision. But if application is still fine with accessing maybe reporting data, which may not be so time sensitive, then they can still access this data on the secondary, even though the primary is down. We'll restart the primary instances for both 2012 and 2014. Okay, we'll do another demo where we stop the secondary. So this time we have stopped the primary. So let's stop the secondary. Okay, first let's verify that everything is fine here. I'm just going to reopen this to confirm. Okay, so this we are good on. We are good in 2012. We'll go to 2014. We are still good here. Okay, let's start the secondary service. So basically, I've named the secondary as equal to on board. So secondary is being stopped. name stuffing secondary here. Okay, let's verify that it's stopped here also. Yeah, great. So if we go to 2012, the earlier version, let's go to the primary and let's look at the error log. I'm going to increase this view. So here we can see that I mean a connection timeout has occurred to the SQL2 replica. We expect it, right? Here it says a connection timeout has occurred with to the database on replica. But note here that it says okay. So let's go for a moment to 2014. Just going to increase this area. Okay, I want to show you something here. I'm going to copy this 2014 message. I hope it gets copied. You can live. Yeah. Okay, and this is the 2012 message. So the thing is, you know, when there are just one or two databases, it may be simpler, but when there are more databases, more replicas, more availability groups, more such environments, it can get a bit complicated. So in 2012, okay, that okay. So this is under the category of supportability enhancements, simply because it helps troubleshooting. It helps anyone to look at the data better. It says, okay, connection with secondary database terminated for primary database. In this case, we know it is an issue. We know the reason of it, but assume that we did not know. We have to troubleshoot which instance it is. It would not be very easy, simply because it would say, okay, with replica ID, and it has to be a huge GUID. We would have to query SQL, you know, to know the GUID at the value of that GUID at that point in time. But with 2014, it's much simpler. We don't have to go to SQL, get the value, and all that. The message directly tells us, okay, availability group connection with for this database terminated, and on this replica. So we know that, hey, I mean, next we need to go and investigate this replica. We don't spend time trying to search, you know, based on the GUID on which is the exact replica. So there have been many such enhancements in terms of making the, you know, the troubleshooting logs easier to read, easier to interpret for everyone, and this generally benefits everyone, right? So this is one such enhancement. I'm going to start this again. Okay, now returning to 2014. Okay, returning to 2012 actually. Okay, here we can see that you know, connection timed out. Okay, and you know, yeah, the connection timeout for you know, at the instance level and at the database level. If you go to 2014, okay, we see a lot more information in terms of you know, setting synchronization states. A lot of it can be like internal debugging information, but you know, when we talk about things like having the replica name, it's always a benefit. just so that we don't have to go to SQL, get the data and all that. It's directly available in the logs. So from here we know, hey, okay, connection to 20 SQL 214, there was a problem. So let's just go to SQL 214 and check what it was doing at that time. Okay, I'm going to start this service too. Okay, this is fine. Just before we go to the next demo, I just want to check that this is fine. Yeah, great. Okay, something that we should not be doing. Okay, but the reason I'm telling is because of the logging behavior. So what we should not be doing is managing the availability group or its resources using failover cluster manager. Okay, I mean it's possible to manage them here also, but okay, but this is not a suggested way. In fact, it can lead to unexplained behaviors. In fact, so it's also documented publicly that everything for SQL AG resource, the availability group resource, should be managed within SQL Server. But just imagine that for a moment that someone does this. Okay, he goes here and maybe he or she goes here and stops the AG. Okay, now let's go to, so now that they have stopped the AG, definitely the primary will not be available. I mean, even the secondary will not be available. So let's, what we're interested is the logging information, because we talked that, hey, I mean, the logging behavior is different, more enhanced in SQL 2014. So this is SQL 2012. Okay, here we can see that the state of the availability group replica has changed from primary normal to resolving normal, and the state has changed because of a startup issue, a failover, a communication issue, or a cluster error. This is okay. So this is what it says here in 2012. Let's go to 2014. Okay, 2014 I will not have started, so let me just go and stop it. So again, this is something that we should not be doing. Okay, whatever management is required should be done using, by right-clicking in SQL Management Studio and doing a failover or doing whatever is required. But I'm showing this for demo purpose. Okay, here the message is a bit different. Okay, it says the state changed because the availability group is offline. I'm going to copy this to the 2012 window so that we can compare it. Here we can clearly see in 2012 it changed because of a startup, a failover. I mean, so this is good info, okay, but it can be a huge range of info, of issues. In 2014, we narrowed it down. Okay, we say the state changed because the availability group is going offline. The only way it can go offline really is, through failover cluster manager. Is going offline because the associated availability group has been deleted or ouch. Let's move to the next line. Or the user has taken the availability associated availability group offline in Windows Server Failover Cluster Management Console. So this can be quite quite helpful for troubleshooting. Sorry, I'll just exit from here. Okay, so I thought I exited. So okay, so it's any way good. I mean, a user, I mean, a DBA or an admin does not have to be surprised. Hey, I mean, it has been taken offline. Okay, at least they know. Okay, fine, someone has taken it offline. So I mean, it's much more. I mean, it's much more clear than having this message. So basically, a lot of messages, a lot of enhancements like this in terms of messages. To make it much more easier for troubleshooting always on availability groups in SQL 2014. Okay, so we have done this demo. So we'll just bring this back online again. So again, it should not be failover cluster manager, should not be used for managing availability group resources. This is just for demo purpose. Show the messages. Okay. Things we good here. And okay, unfortunately, had to be restarted because of system updates. Okay, so but I think we have covered the main part in terms of the differences in 2012 and 2014. So you can see, right, 2012, like how it was there in the presentation, it has the number of replicas is much more. I mean, in 2012 with just 1 plus 4, it will give an error or it will be grayed out after a total of 5 replicas. 2014, we can create up to a total of 9 replicas, 1 primary and 8 secondary. But besides that, the other enhancements are logging related, simply because it gives much more information. And another crucial enhancement is like, even though we stopped, for example, the SQL service on the primary, even though the primary was down in a way, I mean, the secondary could still be accessible in SQL 2014. Unlike SQL 2012, they were not able to access the database. So that means even applications would not be able to access the database in 2012 if the primary was down. Okay, I want to show some more demos. So we'll just, since we know the main differences, we'll just check 2014 for now. So here, okay, 2014, we know, right? I mean, if even if the primary goes down, the secondary is available. Okay, but what if the cluster goes down? So we'll try, turning off the cluster. This should, of course, not be done in a production environment. Okay, so in 2014, the tables, the secondaries are still accessible. The secondary databases are still accessible, even though the cluster is down. In 2012, like how we saw a similar demo for, for if the primary goes down, the secondaries will not be available. Similarly for 2012, if the cluster goes down, the secondaries will not be available. Unlike 2014, where even if the cluster goes down, the secondaries are available. As you can see right now, the cluster is not online, but we can still, expand database. We can query the database. Of course, it's read only because it's a secondary replica, but at least this data is available for, for things like reporting. It's the cluster back. At the time it does its stuff, we go to the error log. Okay, so whenever the database state changes in 2014, the LSN is also noted, including the last commit time. So in case we need to compare across replicas, for which has maybe the latest LSN or the latest commit time, this information is there by default in the error logs. Unlike 2014, which does not have this line above. So again, easier for troubleshooting, easier for an admin or for a user to know, okay, this has later data than the other replica, or some other replica has the latest data. So let's focus on that replica and bring that online. So the last thing that we're going to cover for today in terms of the demo is this function. So in 2012, I mean, to find which is the primary replica, we would have to query the DMVs. But in 2014, run the select F1 header is primary replica. AGDB is the name of the database, I think. Let's verify. That is the name of the database. So if I go to AG1, I can see this is the database in this AG1. So, and this is clearly the primary, right? So if I run this, I'm expecting it to say yes, it is the primary. And it says yes, it is the primary one. Let's run it on the secondary just to have a comparison. So here, I refresh this. So this is a secondary. I'm going to open a new query window and run this. So what are we expecting? We're expecting this to say, hey, is it the primary replica? No, I'm not the primary replica. So let's see what it returns. It returns 0, saying, hey, no, I'm not the primary replica. And compared to this window where it returned 1, yes, I am the primary replica, because this was connected to the primary instance and this was connected to the secondary instance. So this is much better. Like in 2012, we would have to go to the DMVs, in 2012 it's still possible to get this information, but we would have to, traverse multiple DMVs to know the DMV name, to know the AG name, to know the AG group ID, and to find out its current state, whether it's online or not on this replica. So here we can do with just one function. Hey, is it the primary replica? Yes, no. It says yes, I am the primary replica. So again, much more easier for troubleshooting. So as a summary, so two key changes in terms of features for 2014. Okay, one is the number of secondaries have increased from 4 to 8, doubled. Second is, even if the primary is down, the secondaries are still accessible. Now, so these are the two key features. Besides that, there have been a lot of logging related enhancements that we have covered here. Like the error logs have the replica name, they have much more information in terms of commit LSN details or commit time, so we can compare information across replicas. And it's much more easier or much more friendlier to troubleshoot using error logs. The remainder of the slide basically talks about the same thing that we talked about, so I'm just going to zoom across. So this is the same LSN that we were talking about, that we saw. Even when we go to X events earlier did not have the replica name, but now they have the replica name also. So it's easier to troubleshoot, right? I mean, if we just had the availability replica ID and alphanumeric number, we would have to go to SQL, query the DMV, and get that information. Here it's much more simpler. We can see the replica name that's highlighted. If it started in first quorum, SQL 2014 says clearly, hey, I was started in first quorum, or Windows cluster was started as first quorum. This information is not there explicitly on, in SQL 2012. So again, much more familiar. So this we saw, even if the primary is down, the secondary is accessible. You just need to directly connect to the secondary for this information. Okay, so there is something that's generally a frequently asked question for such demos that I see is it's because 2014 also has another key enhancement, and that's in-memory optimization. So in-memory optimization, for the earlier name hackathon, they are in-memory optimization can be enabled for databases which are part of AlwaysOn, so they both work together. Is there anything that we need to be aware of? There is. Okay, in-memory optimization is meant for very high workloads, so maybe a bit small to read. I'll try to expand it. Okay, so there is a threshold that's calculated. Okay, an internal threshold. This information is documented publicly on books online also, for the secondaries to get the data. So there may be a slight delay, though this delay is not even noticeable most of the times. Yeah, and of course, in the optimization, there is one more option where a table, for example, can be created with durability of schema only. That means the data does not persist after a restart. So such information is not logged. Okay, since it's not logged, it cannot be transferred by AlwaysOn. Now, on the primary, we don't have data, so definitely on the secondary also will not have data that will persist, or we won't have data for such tables on secondary replicas. Okay, I'm done. So if there are any questions, feel free to tell. I'm interested in mine. So again, the key takeaway is 2014 has two features which must be known. One is doubling the number of secondary replicas. Second is, even if the primary is down, secondaries are available. This is only in 2014. And the third part is it has many enhancements in terms of that are easier for logging. And of course, the fourth part is the function that can in one call, can just give you whether this is the primary for the database or not. Okay, I think the first question, yeah, I may have to skip, okay, because the question is what is different between MySQL and MySQLi. We are not covering MySQL here. This is a SQL server, so this would not be the appropriate forum for this question. Okay, I'll go to the second question. Hi, if we are adding a new database to an AG, do we need to drop and recreate group again? No. We can, so assuming that an availability group exists, Divya, we can always add a database, or we can drop a database, even if okay, so we can add a database, or we can even drop a database without having to drop the availability group. This is available in 2012. This is available in 2014 also. So I'll move on. Let me know if there are any more questions. And I think this is also documented on MSDM. Vijay, would it be possible to share the slide deck after the presentation? Yes, I think this will be hosted online as far as my understanding goes. Okay. I hope that answers your question, Adarsh. Okay. Guna has asked how much data loss in the sync replication on AlwaysOn. Actually, there should be no data loss at all. It's data latency that will be there. Because it's when it's asynchronous. That means I mean, we don't wait on a commit for the data to be transferred. The data is transferred later. So it's just a matter of when SQL can transfer the data, and SQL will try to transfer it as soon as it can. So it's just a matter of latency. But latency is really not a question, because we are making it an asynchronous replica. So we are saying it's asynchronous, so that means we can tolerate some latency. There should not be any data loss for async replica, but there will be some latency. A synchronous replica will always have data which is there on the primary, But an asynchronous replica, because it's marked asynchronous, SQL will first commit it to the user and then will try to send it to the sync replica. So there can be a slight data latency, which usually is not much, assuming that everything is fine, but no data loss. Okay, I hope that answers your question, Guna. How many availability groups can we make? Actually, this is a good question. So Sunil, there is no limit. There is no technical limit on how many availability groups can be made or can be created. But then we have to note that when we create an availability group, there are resources assigned to the availability group. For example, the primary has one thread for each secondary replica for each availability group. The primary has a thread for for the log on each primary database. The primary has a thread for a secondary database. Okay, the secondaries have their own threads. So we're talking about a lot of threads being used. So that means a lot of resources getting consumed as the number of availability groups and the number of availability databases get created. So what I would say is, don't do too much. There's no limit, so it's like almost unlimited. But a tested rule, a tested thing, maximum is like 10 availability groups with a total of 100 databases. But again, I would not go completely with that, because a database which is like heavily used, may more than make up for 100 databases which are not frequently used. Okay, so it all depends on the workload. But just so it's known, the tested maximum is 10 availability groups with a total of 100 availability databases. And again, it really depends on the workload for those databases, and it depends on the resources on that server. This is also documented on the MSDN site. I hope that answers your questions. Falguni has asked, thanks for sharing. I have a question on failover point. Why is it only recommended to do failover from SQL Management Studio? Oh, it's an interesting question. So the thing is, I'll give you an example. Okay, suppose we were talking some time back on async replicas. So if a replica is in an asynchronous mode, then that means there is data latency. It may not, just a hypothetical example, okay? It may not have the latest data. So we would not want to fail over to a replica which does not have the latest data. But who knows about this? SQL knows about it. Does cluster know about it? No, cluster does not know about SQL. Cluster does not know about databases in SQL. Cluster does not know about data in SQL. For cluster, for Windows cluster, SQL is just another application. So if we give cluster the sort of go ahead to fail over at will, it will not know which one to fail over, and that would not be right in terms of the SQL point of view or from the data point of view, because it's possible that some replicas may have the latest data which SQL would know, SQL or the DBA. So that's why we don't give that decision to the Windows cluster, and that's why we suggest, okay, don't make any changes or don't do anything from Windows cluster, and do everything or manage the availability group from SQL Management Studio. There are other reasons also, but they more or less go along these lines. I hope that answers your question. Any impact on performance by increasing number of secondary replicas? Praveen, yes, and that is why we don't suggest having too many replicas, or sometimes replicas are required. But then what we may not suggest is increasing the number of availability databases beyond what can be handled by the primary server. So I'll show you something. Because this is good info. So we have this document online on SQL prerequisites. Okay. So is the search for this thread? Yeah. Thread usage. You'll see that that there can be a minimum of 3 to 10 threads, but then as the number of secondary databases increase, we create additional worker threads. As the number of secondary replicas increase, we create additional worker threads, and so on. So that means, the more databases that we have, the more replicas that we have, the more resources are required on the primary to manage these threads. So that's why. I mean, this would be the impact on performance by increasing the number of secondary replicas. There is also another point. The number of secondary replicas, if they are synchronous replicas, then the application or the user will have to wait, or SQL will sort of make the user wait for a commit for a commit confirmation from the replicas before committing it to the user. And if these replicas take time to commit, that means the users will be impacted. So generally, we would suggest having at least one synchronous replica, and maybe the others could be asynchronous. Okay, so that would be the impact of performance in terms of resource consumption on the primary, and in terms of commit latency for applications on if there are multiple synchronous secondaries. Okay, I hope that answers your question. Can we connect the primary even if the cluster service is down? Yeah, I think Adarsh is no longer here, but yes, we can connect. In fact, one of the demos was on this. We put the cluster service down, or no, to the primary. We cannot connect to the primary because the primary is a read-write workload. The secondaries can be connected in 2014. How to create a table in database? I mean, this is create table. We can use the SQL Management Studio, and this really would not be in this presentation. But yeah, I mean, this is like a normal table create. Kanupati asks, would like to know, even when the cluster service is completely down? Oh, yes. So our demo was we brought the cluster service completely down, and the secondary replicas were still accessible to SQL Management Studio. And that means they would even be accessible from an application. So yes, I hope that answers your question. Now for SQL 2014 AlwaysOn, which Windows server can be used? Windows 2012? Oh yes, Windows 2012 can be used. So this would be, so that SQL 2014 prerequisite in terms of system requirements would apply to the OS requirements for installing SQL 2014 would apply to AlwaysOn also. Okay, so and this is also, the hardware and software requirements for SQL 2014 are publicly documented. So Sunil, I hope that answers. Are there any enhancements to use AlwaysOn for disaster recovery? Falguni asking. Well, actually, so when we increase the number of replicas, so that means we can have more replicas at offsites. For example, we can have more replicas that are maintaining copy, and we have we have more copies of the replicas. So this is all disaster recovery. If we have more replicas, we can also distribute the backup load in case we want to take backups and move them to some other server. So this feature of adding more replicas directly helps disaster recovery, besides of course helping applications access the data. I hope that answers. Ganpati, we can connect SQL Server replicas. Is this the enhancement? We can connect SQL Server replicas even, or rather we can connect secondary replicas even when the primary is down. So that's the enhancement in 2014. Okay, Ganpati. So I think what is the difference between drop table and DT table? That would really not be the scope of this. But then I think an internet search will clearly give this. We're dropping the table and we are deleting information. Ganpati also available in 2012. No, this is an enhancement for 2014 in terms of if the primary is down, secondaries are still readable. That's available from 2014. Can you tell the AlwaysOn SQL features in details? Actually, we intend to do a webcast just dedicated to AlwaysOn, Mamta. This one was on AlwaysOn enhancements in 2014. But for a full feature, we would probably be doing some future webcast on this. But till then, if you go to if you just type SQL AlwaysOn on the internet search, that will take you to the SQL always on page on MSTN, and that will have all the features for SQL always on. So do attend the next webcast. Okay, I think Ganpati is. This is the same question. Okay, we are just 3 minutes away. And how they fail over when the cluster service is down. So when the cluster service is down, there's no question of failover unless it's forced. But yeah, the enhancement is when the primary is down, we can still read from the secondary, or basically the secondaries are still accessible. It makes a big difference for reporting and all. So that reporting is not affected just because one server, the primary, is down. Okay, Kanpati. Where can we take a backup in AlwaysOn, primary or secondary servers? We can take on both. So that's the advantage of AlwaysOn. We can take on any server which we wish. Okay, but since we can take it on any, we might as well take it on secondary so that we don't load the primary, right? So yeah, so we can take the backup anywhere, but the preference is secondary. So if I go to the AlwaysOn properties for a moment. Okay, we have a tab, we have a section for backup preferences. Okay, so here it says, prefer secondary only, or any replica, or primary. So here we have even automated it so that it automatically can, so we can just run a function to say, hey, is this a preferred replica? If yes, take a backup from here. And generally we would say, okay, take it on the secondary so that we don't have much load on the primary. I hope that answers you. I think Guna, we have covered this. The performance is more like an overall impact simply because of more resources used on the primary replica to manage the secondary replica, or to manage databases on the secondary replica. Besides that, if the secondary replica is configured for synchronous commit, okay, there can be an application latency depending on how much time it takes to commit, or how much time it takes to send data and commit it, from the primary to the secondary. So those would be the two types of impact: application latency possibly, and overall performance impact on the primary due to more resources being required to manage this each secondary. If the primary taking backup means it is overloaded, so taking backup in manual secondary is severe, but log file is growing like anything. No, actually, once the log backup is taken, even on primary or on secondary, it's truncated on both. So as to maintain consistency. So if the log file is still growing, then I think we would be back to our normal troubleshooting. Even without AlwaysOn, if a backup is taken, okay, why is the log file growing? So this could be due to an open transaction or so on that will need to be checked. So this is probably not related to AlwaysOn essentially. But yes, it will be regular troubleshooting, like checking for open transactions and also. So are there any changes in disaster recovery configuration? I didn't get this question, Seema, but yeah, but the changes would be, we have more replicas available even if primary are down. So that by itself says, hey, we have the data and the databases available in case of a disaster. Okay, Sunil, please tell about backup preferences. So this is applicable for 2012, 2014. I'm just concerned that we are exceeding the time. Okay, so but backup preferences, if we right click, and this is not an enhancement, considering this is there on both 2012 and 2014. So we have a couple of options. One we say, okay, prefer the secondary. So that means if the secondary is not available, it's a preferred option. If it's not available, do it on primary. Secondary only. So even if the secondary is not available, only try on the secondary, or primary only. This should not generally occur, but in the rare cases we may need to select this, like when setting up AlwaysOn, and any replica. So this is a bit too random. Given a choice, this is the preferred one, simply because we are, not allowing primary to be loaded. I hope that answers something to you. Incorrect syntax near the keyword select. I don't think this seems to be regular T-SQL thing, not really related to AlwaysOn, Anil. Okay, any major issues with that you have faced when ages were taken offline by Windows, maybe data loss corruption. I would not expect data loss database corruption, but then considering that it's not a suggested way, I mean, I would prefer not anyone not doing it completely. The major issues very fact that we faced is DBAs saying, hey, I mean, someone did this, they did not even tell me. So that's never a good situation, right? So best is to do it from SQL Management Studio and of course through the DBA. Okay, but yeah, the suggestion is to always use SQL Management Studio. So please do not use Failover Custom Manager. And we have a .ndf file as replica with synchronization, so that well, yes, it's I mean since the log is being log data is being transferred from one replica to the other, the MDF is also getting synchronized on its own with the in all the replicas. So I hope that answers the question. And that will also increase the availability. Out of 8 secondary replicas, how many can be synchronous, Bhargavi? So basically, the number of synchronous replicas is still 3. It was 3 in 2012. It's still 3 in 2014. I wouldn't suggest, even if there was an option to increase, we have to understand that if we increase it more, then the latency to the application increases. So anything more than 2 should be a question mark on whether it's really needed. But the number of repetitive answers is 3, and it was 3 in 2012 and 3 in 2014. How to on-pivoting multiple columns? This is really a T-SQL programming question, which would not be appropriate for this session. But I think there are multiple online means for this. Cluster service down, and we can connect SQL Server replicas. Is this enhancement for SQL 2014, or is this works in 2012? Cluster service down in 2012, nothing is accessible. In 2014, the secondaries are accessible. So it's an enhancement for SQL 2014. Are there any benefits in timing of failover? Okay, failover from one node to another takes less time than 2012. No, actually, so the thing is, like, failover generally doesn't take time. What generally takes time is the startup of the databases. And the startup of the database is dependent on the recovery time, and the recovery time is dependent on the number and the size of the log file, the size of the virtual log files within the log file. So the same things that would be applicable for a traditional SQL service startup, in terms of database recovery, would be applicable. So failover by itself generally doesn't take time. It's more the database recovery that takes time. So best practice would be to have a log of reasonable size, 1 GB, 2 GB maybe max. Yeah, but and not and with very with not many virtual log files. Of course, it all depends on requirements. Okay, so I hope that answers. So is the SQL Enterprise version required for AlwaysOn? Can we test it with developer version? Enterprise edition is required for 2012 and for 2014 for implementing AlwaysOn availability groups. Can we test it with developer edition? Yes, because developer edition has all features of enterprise edition. The difference is developer cannot be used in production, but yes, it can be tested in developer. Is SQL 2014 improved on the AG failover as compared to 2012 in terms of reduced downtime? Hitul, failover should not take time. It's the database recovery that takes time. Okay? And like how we talked about, it's like log file size and number of virtual log files. Okay, I hope that answers. If any change is done in primary, it may reflect in secondary. Yes, it will reflect in secondary. How soon will depend on whether it's a synchronous replica or an asynchronous replica. Okay, so trying to answer these questions, as quickly as possible, but as completely as possible, just in the interest of time. We've already exceeded, I think, by 6 minutes. Does the AlwaysOn can be automated by using T-SQL script? That is, whenever a new database created, it should be moved into AlwaysOn group. Provide relevant KB article. So Ganpati, it can be done. I mean, I don't know of any KB article, but don't see any need for a KB article. For example, if I make any change, okay, or let's say if I want to say failover, this applies to almost everything within availability group. So, and this is there in 2012 and 2014 also. Click on next. Okay, I have the option of scripting it out. Okay, so I can click cancel here and have the script. So yes, there's no explicit KB for it, but this is available in SQL Management Studio just by clicking on the script button, like how I just showed. So you have the script available for which can be used next time or this time. I hope that answers Ganpati. Can we use developer edition for AlwaysOn? Yes, because developer is the same as enterprise. Maybe only thing is developer is licensed for use in test environment or developer environment, not in production. Cool. I hope that answers a lot of questions. Thank you so much.
Thanks for the insightful presentation, Mr. Vijay. If you have any other questions that you people need to ask, I would request Mr. Vijay to kindly share his email ID so that he can answer all the unanswered questions then and there.
Yeah, cool. Yeah, my email ID is Vijay My name is Vijay Rod. It's Vijay Rod, VIJAYROD at Microsoft.com. So if there are any questions about database engine, AlwaysOn, Azure, feel free to email me. Most of this information is there on the internet. But yes, if you feel I can help you in some way, yeah, feel free. Thank you.
I'm really thankful to our guest speaker, Mr. Vijay, for conducting this webinar. It was indeed a great session. I would also like to thank all our participants for their support in making this webinar a success. The recording of the webinar will be available on takeik.com by tomorrow. Thank you all for joining us today.
Thank you, Shweta.